Hey everyone and welcome. So today, we're going to dive into an invisible force that, believe it or not, shapes pretty much everything around us. I mean, from the atoms in our own bodies to the lightning that streaks across the sky. We're talking about electric fields. And to get our heads around it, we're going to start with a feeling I guarantee you've experienced before.
You know that feeling, right? That little zap you get on a dry day. You go to grab a metal doorknob, and right before your finger even makes contact, you see a tiny spark jump. It's kind of annoying for sure, but it's also the perfect way to start understanding one of the most powerful and fundamental forces in the entire universe.
All right, so let's really get into that shocking feeling. Because if you can understand what's happening with that tiny little spark, you're well on your way to grasping a concept that is, well, it's huge. It all kicks off the second you start walking across a carpet, especially if you've got socks on. You're creating friction, right? And with every single step, you are literally scraping these tiny, invisible particles, we call them electrons, right off the carpet and onto your body.
Now, each of these electrons carries a negative charge. So as they start to pile up on you, your whole body develops what physicists call a net negative charge. Yep, you've basically turned yourself into a walking, talking, electrically charged object.
And that metal doorknob? Oh, it's just sitting there, ready and waiting to balance the scales. The moment your finger gets close enough, all those extra electrons you've been collecting make a huge, sudden jump from you to the doorknob. That tiny little lightning bolt is the spark you see and, of course, the shock you feel. Okay, so why? Why does that jump happen in the first place? To really get that, we've got to look at the fundamental rules that these electric charges play by. So first things first, electric charge is a basic property of matter. I mean, just like mass is. And fun fact, it was actually Benjamin Franklin, way back in the 1700s, who came up with the names we still use today, positive and negative.
And these charges, they follow one simple, golden rule. You've probably heard it before. Opposites attract and likes repel. So two positive charges, they'll push each other away. Same for two negatives. But a positive and a negative, they pull right toward each other. And the particles making all this happen are the positive protons deep inside an atom's nucleus and those negative electrons we talked about zipping around the outside.
Now this next part is absolutely crucial. When you get shocked by that doorknob, you aren't creating new charge out of thin air. The carpet isn't creating it either. It's just being moved around. The electrons were simply transferred from the carpet to you. So the total amount of charge in the room, what we'd call a closed system, it stays exactly the same. All you did was rearrange it.
Okay, so we've got it. Charges attract and repel. But this isn't just some vague tendency, like a gentle nudge. No, this is a real, measurable force. And what's really wild is that it can act between two objects even when they're not touching at all.
Now, you might see an equation like this and think, oh no, math. But don't worry, we're not going to be solving anything. This is what's known as Coulomb's law, and I just want you to think of it as the official rulebook for the electric force. It tells us exactly how strong that push or pull between any two charges is going to be.
And really, this whole law just boils down to two super simple ideas. First, the more charge you pack on, the stronger the force gets. That makes sense, right? And second, the farther apart the charges are, the weaker the force becomes. In fact, it gets weaker really fast as you increase the distance.
But this whole idea of a force acting across empty space, it brings up a really fascinating question. It's a question that actually stumped scientists for a long, long time.
No, seriously, think about it for a second. How does a positive charge over here know that there's a negative charge way over there to pull on? I mean, how do they know the other one even exists? Are they like sending secret text messages to each other? The answer is actually way cooler, and it is the absolute heart of what we're talking about today.
The answer is the electric field. You see, every single charged object, every electron, every proton, doesn't just sit there. It generates this invisible field of influence that extends out into the space all around it. It's kind of like an aura, a force field that actually changes the very fabric of the space it's in.
So to get a handle on this, physicists came up with a pretty clever model. Let's imagine you have one big charge. We'll call it the source charge because, well, it's the source of the electric field. Then we can imagine placing a second, really tiny test charge somewhere nearby. The job of this little test charge isn't to create its own field, but just to feel the field that the source charge has already created.
So how in the world do you visualize something that's totally invisible? Well, we draw what are called field lines. Think of them like a map of the force in that space. And by agreement, scientists decided the arrows on these lines will always point in the direction that a positive test charge would get pushed. So that means the lines always point away from positive charges, and they always point toward negative ones.
And this is where it gets really beautiful. Because when you have more than one charge in the mix, their individual electric fields all add up. They combine to create these incredible, elegant, curved patterns. You can see the lines flowing from the positive charge to the negative, and they trace out the exact pathways of force through space. The charges don't need to know about each other anymore. They just react to whatever the combined field is doing right at their exact location.
All right, so we've got this invisible map of force all laid out. The big question now is, so what? What actually happens when you place a charge onto that map?
And here's the thing to really lock in. That field is there whether or not there's a second charge around to feel it. The source charge has already changed the space around itself. The real magic, the action, happens when you introduce another charge into that field that's already there.
And here it is, the big payoff. The field puts a real physical force on that new charge, a literal push or a pull, and we all know from basic physics that when you apply a force to something, it accelerates, it moves. So the invisible field creates visible, totally measurable motion. This isn't just theory, this is the engine behind everything from the touchscreen on your phone to how wireless chargers work.
So from that little shock you get from a doorknob all the way to the complex motion of subatomic particles, the electric field is just a fundamental part of our reality. It kind of makes you wonder, doesn't it? Beyond the electric fields that are all around us right now, what other invisible forces, what other unseen fields are shaping our world at this very second? Something to chew on. Thanks for tuning in.